Okay, everybody. I just want to do a review for your final exam and just kind of go over the details. Your final exam, hopefully you've received the emails and just double check. The seniors, your exam will be Friday, May 14th. You got to come into the school from 9:45 to 11:15. Juniors, the next week, Friday, May 21st. You finished the last test, the unit, I believe, 10 test. You should have finished that on Monday, May 3rd. So you basically have from then until that point until the May 14th or May 21st to review for the exam. The review that you're going to receive is basically going to be what your exam is over. It will not include anything outside of those topics. And it can include most, if not all, of the questions that you see. The formulas at the top will be the ones that you are given. You'll need to know the others. There's a couple others you'll need to know in terms of maybe converting polar coordinates to rectangular or rectangular to polar. But you will have at the top of the page the ones that you see on the review sheet. I'm going to break this up into sections. We're on the videos. I'm going to go through all the work. It's been a while, I'm sure, since some of it. So I think this will be helpful for you. You do not need to turn in your review. This is just for you to do. The last thing you need to do is the actual exam itself. So we're going to get started on the Unit 7 review. Unit 7 was applications of trigonometry. It's covered with problems 1 through 5. And then so I'll do another video on Unit 8, another video on Unit 9, and another video on Unit 10. So we will hit all the problems in the review. And we are just going to go through the review problems. All right, when solving different types of triangles, we use either law sines or law cosines. There is one case, which is called the ambiguous case, which could result in 0, 1, or 2 triangles. Every other case will result in 1 triangle only. So you do not need to test it other than this one case. And that one case is side-side angle. Okay, that is different than side angle side, and I'll explain it here. So if side-side angle means that you know 2 sides of the triangle, say that's 20, that's 24, and you know a angle that is not included. The included angle will be the angle between. That's not what we want. So it'd be side angle, and say that's 28 degrees. That could have 0, 1, or 2 triangles based upon our work. Everything else will have 1 triangle. Side angle looks like this. This would be, let's say that's 24. And then this is 28. If it's side angle side, then I would need to know that. So that is side angle side, and that has 1 triangle only. Okay, so like we said, this is side angle. Now for number 2, I'm going to tell you that will give us 2 triangles. So you need to list the missing measurements for both triangles. And we're going to round all answers to the nearest 10th. Angle C is 34 degrees, A is 12.1, and C is 9. Well, when you're given the dimensions, you need to draw out the triangle. Any angle, the side across from it also has the same constant. So if this is angle C, the side across from it would be 9. So I'm going to label this one C, and anytime I get a side, and I don't know, I like to put my angle in the bottom left corner. So I'm going to call that C. That's 34 degrees. Across from it has to be side C, which is 9. And I'm going to let this be 12.1. And since that's side A, this has to be angle A. This will be now side B, or angle B and side B. So I got to find angle A, angle B, and side B. Well, when you're doing this, if you look away, everything is set up. The only thing that you can find is angle A using law of sines. So I can say sine of A over 12.1 equals sine of 34 degrees over 9. Well, cross multiply to solve this, and you get 9 times sine of A equals 12.1 times sine of 34 divided by 9. So that means sine of A equals 12.1 times sine of 34 over 9. All right, using your calculus, when you're looking for an angle, you're going to have to use inverse sine. Okay, so I'm going to do inverse. Well, let me do this whole thing first. I'm going to take 12.1 times sine of 34, okay, divided by 9. Okay, that's that whole mess there. So you inverse sine when you're looking for the angle of the answer, and that gives me 48.7 degrees. So angle A equals 48.7. I'm going to go up here and put that for triangle 1. When you're doing an ambiguous case, and there could be 1, 0, 1, or 2 triangles, and once you find the first angle, I think it's most helpful to immediately go to the second triangle and start there. So with the way this works, whatever angle A is, so this is 47.3, in the second triangle, angle A is automatically going to be 180 minus 47.3. So when we do that, we get 132.7. Hold on here. I'm going to pause here for a second. I want to check something. Okay. I don't know what I did there. I wrote 48.7 and then I wrote 47.3, and then it didn't match up with my answers and I wasn't sure what was going on, but I was okay. So that's 48.7. This should be 180 minus 48.7. Okay, so if I take 180 minus 48.7, okay, I get 131.3. All right, here's how this happens in the second triangle. So we got to keep angle C the same, which is 34 degrees. Side C cannot change, it's 9. This is 12.1. This is angle B. Now, here's what happens. Those two won't change. This side is the one that's going to stay the same, but it can move. And if I flip it over here, that can still be 9. Okay, that can still be 9. Now, this side won't be the same. So here's what I got. This is a pretty good representation. So the 12.1 and the 9 are the same. That's 34 degrees. Now angle A, you can see it's clearly not going to be the same. So that's going to be 131.3. To test whether you do have a second triangle, okay, as long as the two angles that we now have are less than 180, I know I have a second triangle. If they're more than 180, I only have one triangle. So I'm just going to figure out angle B for both of them right here. So I'm going to keep with this triangle 2. I got 180 minus 131.3 minus 34. And so that gives me 14.7. So angle B in the second triangle is 14.7 degrees. And then over here, I got 34 and I got 48.7. So I take 180 minus 34 minus 48.7, which is 97.3. So angle B equals 97.3. I'll mark that up here. Now these are two independent cases. I need to find side B in the first triangle. So to find that, I'm going to use the law of sines. I'm going to take the sine of 97.3 over B equals, now I need to use an angle and a side. And go back to your original ones. We want to try to avoid rounded off values if at all possible. I have to use the 97.3 because I need side B, but I'm going to use the sine of 34 over 9. Okay, cross multiply. 9 times sine of 97.3 equals b times the sine of 34. Divide by the sine of 34. Now we're looking for a side here, not an angle, so we do not use inverse. So I can just type that in kind of how you see it. So 9 times sine of 97.3. Let me fix that. Okay. Divided by sine of 34. So I get side B equals 15.96. We're rounding to the nearest tenth, so that's going to become 16.0. And that's in triangle 1. Triangle 2, I go ahead and I'm going to use sine of 14.7, which is here, because we're looking for side B, equals sine of 34 over 9. Cross multiply. 9 times sine of 14.7 equals b times sine of 34. Divide by the sine of 34. And so b will equal, let's see here, 9 times sine of 14.7. Take that answer, divided by sine of 34. 4.1 when I round that. Okay, so I told you there was 2 triangles. I'll do the same on the exam. I will let you know ahead of time. And unless you're told otherwise, there is 1 triangle. And that's only for the side-side angle case. All right, number 3, solve the following triangle for all missing sides and angles. If this is angle A, then across from it has to be side A. If this is angle B, across from it has to be side B, and that means side C is 22 meters. So I need to find A, B, and angle C. Well, angle C, the 3 triangles have to add up to 180. So you just take 180 minus 26 minus 51. Okay, so for that, 180. Minus 26 minus 51. So 103. So angle C equals 103 degrees. All right, so I got all the angles. I just need my 2 missing sides. So let's go for side A, and I'm going to use across from it angle A in the law of sines. So I'm going to take the sine of 103 degrees over 22 equals the sine of 26 degrees over A. Now, cross multiply. I'm not going to write everything out here. So you're going to take 22 times sine of 26 and divided by sine of 103. And I get 9.897. So if I'm rounding to the nearest tenth, that's going to be 9.9. So A equals 9.9. So I had angle C. I got side A. Now, minimum on your exam, you need to show me your this proportional setup, which with the usual law of sines, your law of cosines, and then from there, it's pretty self-explanatory. You want to show the steps that I showed in the previous one where you actually did that's fine, but not as necessary. All right, to find angle B or side B, I got to use the 51. I'm going to stick with the 103 and the 22. Sine of 103 degrees over 22 equals sine of 51 degrees over B. So same thing here, 22, let me clear this out, 22 times sine of 51. And there's no reason you can't put this all in your calculator at the same time. I just prefer to do it a little bit of step by step, but if you just put it all in, it will be fine. And then we get sine, or 17.5 when I round off. So B equals 17.5. Okay, so that's number 3. That one uses the law of sines. All right, let's take a look at number 4. They just give you the measurements. You got to draw the figure out. They give me 2 sides and 1 angle. So potentially this could be a side-side angle. So until we look at it, we don't know. I'm going to label this A, side A. This is going to be B. This is going to be C. And I'm going to put this here as 38 degrees. Side A is 16.7. Side C is 24.2. I have a side angle side case. That means there can only be one triangle. And this will be side B. All right, when you have a side angle side, from what you learned, we can only solve for side B using law of cosines. That is our only option to begin with. Now, law of cosines, the formula you got on your sheet says a squared equals b squared plus c squared minus 2bc cosine of a. Well, there's 3 different forms because I could make the a squared a b squared, just flipping everything around. Well, we are solving for b squared. Well, b squared is going to be the other 2 sides, a squared plus c squared minus 2ac cosine of the angle. So this side and this angle's got to match up. Well, when you're given a side angle side, these 2 are always going to be the 2 sides here, and this angle is always going to go here. I don't really think you have to memorize each case of the law of cosines. You just need to know how to use one of them. So for this case here, b squared is going to equal a squared, which is 16.7 squared, plus c squared, which is 24.2 squared, minus 2 times 16.7 times 24.2 times the cosine of 38 degrees. So I'm going to type that whole thing in. So it's 16.7 squared plus 24.2 squared minus 2 times 16.7 times 24.2 times cosine of 38. Now, one thing you got to watch is that gives you b squared. B squared is approximately, 227.5967. We want b. So take the square root. So the square root of the answer, don't round off to the very end, and we'll round off to the nearest tenth. So b equals 15.1. Okay, so this is 15.1. At this point, we have enough, and you can use the law of cosine to find the angle, but the law of sines is a little bit easier. But there's one thing you got to watch: the law of sines will never give you an obtuse angle. So if you use that, you could end up getting the answer wrong, unless you do the following: unless you find the smallest angle, because it'll be guaranteed to be acute. Angle C is across from 24.2. Angle A is across from 16.7. The bigger the side, the bigger the angle. So 24.2, angle C will be bigger than angle A. So I'm going to look for angle A at this point using law of sines. So I'm going to say sine of angle A over 16.7 equals sine of 38 over 15.1. Now I'm looking for the angle. So I'm going to have to use inverse sine. So I got sine of A, or cross multiply, I get 15.1. Let me fix that a little bit. 15.1 times sine of A equals 16.7 times sine of 38 divide by 15.1 divide by 15.1. Okay, so sine of A equals that whole mess. Now clear that out. 16.7 times sine of 38 equals divided by 15.1. Now, since we're looking for an angle, we do inverse sine of the answer, and I get 42.9 degrees. So angle A equals 42.9 degrees. So we had B, we got A. Well, once you get the second angle, the third angle has to be 180 minus that. So angle C is 180 minus 38 degrees, which is angle B, minus 42.9. So angle C equals clear that out. 180 minus 38 minus 42.9. 99.1. If you would have used the law of sines to try to find angle C, it actually would not have given you that answer. So you have to be careful when you're using the law of sines. It will not give you back an obtuse angle. Now, the last one for this case here, or for this unit, number 5. This ends up being a trig application problem. Two boats leave a dock together, each traveling in a straight line. One boat travels at 18 miles per hour, the other at 24. If the angle between their courses measures 56.7, how far apart are they after 50 minutes? Round your answer to the nearest tenth of a mile. Okay, so they're going on a straight line. So let's just do this. And we'll do this one here. And we'll say the first one is the 18 miles per hour. The second one is 24 miles per hour. And this is the angle between them. This is 56.7 degrees. And it might be a little bit, let me bring that up just a little bit. Okay, we want to find the distance between them. The distance between them is this right here. That is our distance. This is going to be a side angle side case where I use the law of cosines. Well, one thing I got to do is I got to find those actual distances. This tells me if it was 1 hour, it would be 18 and 24, but it hasn't been an hour. It's been 50 minutes, which is 5/6 of an hour. So I can take 5/6 times 18, and that gives me 15. So that means this length down here, this bottom length, is actually 15 miles travel. And then I take 5/6, because you got 50 minutes out of 60 minutes, times 24. So this person has traveled 20 miles. So there's our angle, there's our two sides. So using the law of cosines, which you see is a squared equals b squared plus c squared minus 2bc cosine of angle A. Well, it's whatever side we're looking for and the angle across from it. And then your other two sides go here. Law of cosines for side angle side cases. So d squared is going to equal 15 squared plus 20 squared minus 2 times 15 times 20 cosine 56.7 degrees. Okay, using my calculator, 15 squared plus 20 squared minus 2 times 15 times 20 cosine 56.7. Now remember, that's d squared. Take your square root. and I get 17.2 if I round to the nearest tenth. So distance equals 17.2 miles between the two boats. Okay. All right, this is Unit 7, okay, the applications of trig, and I'll do another video you'll be able to access for Unit 8, Unit 9, and Unit 10. Okay, best of luck.